Hi everyone! So now that we've graphed logarithmic functions, let's graph transformations of them without a calculator. So the first thing that we want to do is graph log base 2 of x plus 3. So remember, when it's inside of those parentheses, it's going to be dealing with us horizontally. And anything in parentheses is lying to you. So even though it says plus 3, we're actually going to move to the left 3. Now I've gone ahead and graphed in there log base 2 of x because we've already graphed that, right? Now we're just going to move everything left 3 units. So earlier, my asymptote was at x equals 0, right? Well, once we move that over to the left, now it's at x equals negative 3. So here's that 1/8, 1/4, 1/2, 1. Good. So my intercept right here is now at negative 2 since I moved left 3. I was at 1. Now I'm at negative 2. And then we'll take each point and move him over 3. And draw our little line. There we go. There's log base 2 of x plus 3. Let's go ahead and analyze real quick. And we're actually going to do end behavior at the end of everything. I'm going to move my face to the other side. All right, so my domain, my x values, instead of starting at 0, now they're starting at negative 3. So I'm going to be from negative 3 to infinity. My range is still from negative infinity to positive infinity. As we discussed, that asymptote at 0 got moved to negative 3, so now it's at x equals negative 3. And my intercept, like we said a second ago, was at negative 2, 0. Like I said, we're going to do end behavior a little bit later. So go ahead and please go ahead and graph and analyze log base 2 of x plus 3, no parentheses. All right, so hopefully your graph looks something like mine. Since we moved up 3, remember down there at negative 3 was 1/8 negative 3, right? So when we shift our whole graph up 3, now my intercept is at 1/8, 0. My domain, my range, and my asymptote don't change from log base 2 of x. So let's go ahead and look at this end behavior. So earlier when we were talking about just plain old log base 2 of x, so our original lower one down here, remember x doesn't actually approach negative infinity. What does it approach over here? It approaches 0. X approaches 0. And as x gets close to 0, y's go down, 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 down. So that's equal to negative infinity. Over on the other side, remember he's going to keep on rising up, 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 up. So as x approaches positive infinity, g of x equals infinity. Okay, now we're going to do the end behavior for the one that we did today. So log base 2 of x plus 3. So we'll go back and look at that guy. Now, we're not approaching 0 anymore over here on the left side, right? We're actually approaching, my asymptote now, negative 3. So as x approaches negative 3 of h of x. Remember, we're going down like that. So that's approaching negative infinity. Over on this end, y is still getting larger and larger and larger, although slowly. So that's also equal to infinity. Please go ahead and try those next two on your own. All right, so that log base 1/2 of x, if you need an explanation, go back and watch the graphing logs video. And over here, this is just another that we shifted up 2. So still my graph is going to be looking the same way. As x gets close to 0, my y's go to negative infinity. As x get really big, y gets really big. All right, so there's transformations. See you guys a little bit later.